Hi everyone, let's get started with today's lesson 2.3 Quadratic Inequalities. An equation is a mathematical statement that two expressions are equal. A statement that one expression is greater than or else greater than or equal to another, we call this an inequality. An inequality with a quadratic expression on one side and 0 on the other side is called a quadratic inequality in one variable. To solve a quadratic inequality, we have to find the range of values of x. There are three methods that can be used to solve a quadratic inequality. They are graph sketching method, number line method, and table method. We usually use interval notation to describe the set of solution. Before we solve quadratic inequality, let's recall some property on inequality. Basically, if a and b are real numbers and a is greater than b, when we add, minus, multiply, or divide a positive constant, we did not change the sign of the inequality. But if we multiply or divide a negative number, we have to change the sign. So this is shown in property number 3 and property number 4. So we have to take note about that. Let's look at example 2.3.1. Find the range of values of x for the quadratic inequality x plus 2 squared is lesser than 2x plus 7 by using the three methods. First, let's rearrange the quadratic inequality. X plus 2 squared is lesser than 2x plus 7. Expand the bracket and bring all the terms to one side. We get x squared plus 4x plus 4 minus 2x minus 7 is lesser than 0. Simplify the inequality. We have x squared plus 2x minus 3 is lesser than 0. Then we factorize the inequality. X squared is divided into x and x. 3, there's only one combination, 3 and 1. In order to get a positive 2x, we add 3x minus 1x, and we check plus and minus, we get a minus. Therefore, x plus 3, x minus 1 is lesser than 0. When x plus 3, x minus 1 is equal to 0, we get x is equal to negative 3 and x is equal to 1. That means the graph will intersect the x-axis at the point x equal to negative 3 and x equal to 1. Then we let y equal to x squared plus 2x minus 3, which is x plus 3, x minus 1. By doing so, we are finding the range of values of x where the y is lesser than 0. The first method, graph sketching method, we have the x-axis and the y-axis. X squared plus 2x minus 3, we have a positive a coefficient, so it's a smiling curve, and it will cut through negative 3 at the y-intercept. The x-intercept will be negative 3 and 1. C is negative 3, x-intercept is negative 3 and 1. Let's divide the x-axis into 3 sections. This section is x is less than negative 3. The middle section is x is between negative 3 and 1. And this section is x is greater than 1. The section above the y-axis will be y is greater than 0. And the section below the x-axis will be y is lesser than 0. we need to find the range of values of x where y is lesser than 0. This is the section we are looking for. And the parts of the curve that lies in this area is this part, which is x is between -3 and 1. Therefore, our answer will be x is between -3 and 1. For the second method, number line method, we draw a number line, which is the x-axis, and our x-intercept is -3 and 1. Same thing, we divide the number line into 3 sections. This section is x is less than 3. The middle section is x is between -3 and 1. And this section is x is greater than 1. Then we choose the values of x that satisfy x is less than -3, x is greater than 1, and x is between -3 and 1 on the number line and substitute them into y. It means we choose a point from this area. Let's say the test point is -5. We substitute the -5 into y. We have -5 plus 3, -5 minus 1, which is equal to -2, -6, equal to 12, greater than 0. So we have a positive value. Same for the middle section. We choose a test point in between the range. For this case, we choose 0. Substitute it into y. 0 plus 3, 0 minus 1. We have 3 multiplied with -1 is -3, lesser than 0. So it's a negative value. For the last section, we choose a test point greater than 1. So let's try a 2. Substitute into y. 2 plus 3, 2 minus 1. We get 5 multiplied with 1 is a 5, greater than 0. So this section, we will get a positive value. Recall back on our questions. We need to find the range where the y is less than 0. That means a negative y value. So this one fulfill the condition. Therefore, the range of values of x that satisfy the inequality is x is between -3 and 1. Method number 3, the table method. First, we need to draw a table. For this row, we fill in the range of values of x. X is less than -3. X is between -3 and 1. And here is x is greater than 1. For this column, we fill in the factor x plus 3, x minus 1, and the multiplication of the two factors, x plus 3, x minus 1. The method is somehow similar to the second method. We choose a number that is less than -3, example -5. We substitute it into the factor. -5 plus 3, we get -2. So this is a negative value. We substitute -5 into x minus 1. We get -5 minus 1, -6, a negative value. Negative multiplied with negative, we will get a positive number. For x is between -3 and 1, we choose 0. Substitute 0 into the factor. 0 plus 3 is 3, positive. 0 minus 1 is -1, negative. A positive multiplied with a negative, we get negative. For x is greater than 1, we choose 2. 2 plus 3 is 5, positive number. 2 minus 1 is 1, a positive number. A positive multiplied with a positive, we will get a positive number. Since y is lesser than 0, then the range of values of x is determined on the negative part of the table, which is this. Hence, the range of values of x is between -3 and 1. When solving quadratic inequality, you can choose either one of the method to solve, unless the method is stated in the questions. Example 2.3.2. Solve 4x minus 5 multiplied with 3x plus 1 is greater than 0. For this question, I will use graph sketching method to solve. When 4x minus 5, 3x plus 1 is equal to 0, our x is 5 over 4 and also -1 over 3. These 2 points are our x-intercept. Then we sketch the graph. Here I will just sketch the x-axis, and we have a positive x square, so it's a smiling curve. Cut through the x-axis at -1 over 3 and also 5 over 4. And we are looking for the area which is greater than 0, means above the x-axis, here and here. Therefore, the range of values of x that satisfy this inequality is x is less than -1 over 3 and also x is greater than 5 over 4. Number 2, find the range of values of x for which 3x squared is lesser than x squared minus x plus 3. 3x squared lesser than x squared minus x plus 3. We rearrange the inequality. 3x squared minus x squared plus x minus 3 lesser than 0. Simplify it, we get 2x squared plus x minus 3 lesser than 0. Then we factorize it. 2x and x. In order to get 1x, we have to write a 3 here and a 1 here, because this will give us a 3x and this part will give us a 2x. To get a positive x plus 3x minus 2x. And don't forget to check plus and minus, we get a minus. When 2x plus 3, x minus 1 is equal to 0, x is -3 over 2 and also 1. Let's try using graph sketching method again. We draw the x-axis. We have a positive x squared, so it's a smiling curve. Our x-intercepts are -3 over 2 and 1. We are looking at the area which is lesser than 0, meaning below the x-axis, so here. Hence, the range of values of x that satisfy the inequality is x is between -3 over 2 and 1. Example 2.3.3. Find the range of values of p for which x squared minus px plus p plus 3 equal to 0 has real and distinct root. State the values of p such that the equation has coincident roots. The information we have are x squared minus px plus p plus 3 equal to 0. Has real and distinct root implies that b squared minus 4ac greater than 0. So the first thing, we are asked to find the range of values of p. Our a is a 1, b is a -p, c is p plus 3. Let's substitute the a, b, c into b squared minus 4ac greater than 0. -p bracket square minus 4 times 1 times p plus 3 is greater than 0. Expand the inequality. P squared minus 4p minus 12 is greater than 0. Then we factorize the inequality. P squared is p and p. 12. 12 we have 1 and 12, 2 and 6, 3 and 4. We need to get a negative 4. This combination will give us a 4. 2 and 6. To get a negative 4, we have to minus 6p plus 2p. And lastly, need to check positive and negative, we will get a negative. When p plus 2, p minus 6 equal to 0, p is equal to negative 2, p is equal to 6. This is our intercept. Then we sketch the graph. This is the p-axis. We have a positive p square, so it is a smiling curve. The p-intercept are negative 2 and also 6. We are finding an area which is greater than 0. It will be the area above the p-axis. Hence, the range of values of p that satisfy this inequality will be p is less than negative 2 and also p is greater than 6. State the value of p such that the equation has coincident roots. Coincident roots implies that b squared minus 4ac is equal to 0. For this question, it also implies that p plus 2, p minus 6 is equal to 0. So we are finding the p-intercept, which is this point and also this point. Therefore, the value of p when the equation has coincident roots are p equal to negative 2, p equal to 6. From all this example, we can conclude that if we have a graph that looks like this is our x-axis. Let's say this is A and this is B. This section is x is less than A. This section is x is greater than B. And this section is x is between A and B. When y is greater than 0, the area will be this part and this part. Therefore, the range of x will be x is less than A, x is greater than B. When y is equal to 0, we have these 2 points, the x-intercept. X is equal to A, x is equal to B. When y is lesser than 0, then the answer will be this part, the area below the x-axis. So the range of values of x will be x is between A and B. For the next section, we will discuss more questions on quadratic inequality. You may try the questions and see how much you understand about this topic. In the next video, a detailed solution will be given. Good luck in trying the questions. See you again in the next video.